Hi all, this is day 100 of my GATE CS prep. So yesterday I did this example based on the asymptotic comparison, and like few were remaining, so I just finished and I started recording it. So you can see we need to arrange the below function in increasing asymptotic order. So few functions are given and we need to arrange in increasing order. You can see n to the power 0.1, root n is there, and which can be written as n to the power 0.5, n square and log n is given. So first just number it like 1 2 3 4, and first step is you need to check if we can directly compare it or not, and if possible so here all three first terms are polynomial because something raised to n is there. So and we can compare between those three. Smallest power is 0.1, then 0.5, and then 2. So 1 is less than 2 is less than 3. Now we can compare 1 with fourth function. Each of these three need to compare with fourth one. So you can see n raised to 0.1 is less than n log n. So here we can do direct comparison since polynomial and power of n raised to 1 log n. So which is greater, and second is n to the power 0.5 less than n to the power 1 log n, again which is less than n to the power 1, so 3 is less than 4, and n square and n log n. So we can cut n and n, which is second step to check if something we can cut. So here n would come and here only log n would remain, and n is always greater than log n, so it's greater than 4. So finally it comes like 1 is less than 2 less than 4 less than 3. That's the answer. So here we need to arrange in increasing asymptotic order. 2 raised to n, 4 raised to n, 1.0, 1 raised to n. So here after giving numbering you need to check what is relation between them. We have seen the shortcut like sequence to remember the function, right? Constant, exponential, polynomial, logarithmic, then factorial, and n raised to n. So we can see the relation here, so we can directly compare from this relation. So smaller is polynomials. You can see again here 1 2 3 4, smaller is polynomial n raised to 10. This is like 5th 6th, this is the same order that which is correct. So directly we can compare 4 3 1 2 5 6. So here arrange the below function in increasing asymptotic order. All log to the base and something n. So check if direct comparison can be possible, and so here we cannot do because bases are different. Second is can we simplify? We can't simplify anything here, so the last step is to apply log. It does not matter because log of log always gets ignored, so all three steps failed. Now we need to convert with the formula that we have written, and we need to remember that, which is log b to the base a. So log b to the base c and log a to the base c would come, and here log of 10n would be broken as log to the base 2n upon log to the base 210. There is rule, or you can say rule only. Constant is independent of n in asymptotic comparison, so remove constant. So the numerator term will get completely removed because it's constant, and n is independent of constant. So answer is log to the base 2n. You can see the same formula would go for the second two terms, and all are equal here. You can see here only log to the base 20n, like in log to the base 2n, log to the base 220. So the numerator term would get ignored. A denominator term would completely get ignored, which is that here this is denominator, and again it would equal. So there is note from this example only. You can see if one logarithmic function is different from another logarithmic function just by constant base, then they will be considered asymptotically equal. So if in the denominator you can see any constant like log to the base 210, then that all these three terms would considered as asymptotically equal only. So arrange below function in asymptotic order. They have not mentioned increasing asymptotic order or decreasing asymptotic order. They have just mentioned asymptotic order, which is you can arrange in either increasing or decreasing, any that you find the relation. So first give number, and here all are logarithmic functions, so they just assume log equal to k, so it would be easier. Can do direct comparison since 1, 2 are polynomial. You can see first 2 are polynomial, n to the power something, so it's polynomial, and 3, 4 are logarithmic, and fifth is smaller because larger the logs are there, then smaller would be the value. So that's the relation. So fifth would come first, then 3, 4, because of course log are less than polynomial, and that's how the relation is. This is 2 to the power n, 2 to the power 2n, 2 to the power 2 to the power n. So bases are same here, and powers. So direct comparison between powers would happen because all three bases are same here. Check power in below, which is, so they have given this example. Okay, if it is like 2 raised to n plus 2, then you can divide it like 2 raised to n, not divide, you can separate the terms in terms of like 2 raised to n dot 2 raised to 2, and 2 raised to 2 is constant, so you can remove that. Most dominating term will be like 2 raised to n, not because this 2 raised to 2 is constant, so relation would be 2 to the power n, then 2 to the power 2n, and then 2 to the power n only. So again here asymptotic order, either increasing or decreasing. All are given like n square, n to the power log n, root n, log n to the power log n. Let's see. Need to check if we can do the direct comparison. Like from increasing, like which start from the smaller value goes to tell big polynomial, log which is smallest. First 3 polynomial are there. You can see n to the power something is there. So first 3 are polynomial, last is logarithmic. Log is the smallest of every one. So and f5 is different, like log to the power log n is given. We need to compare the because directly we got the relation. First 3 are all are polynomial, and f4 is log n, so f4 would be the smallest of all, and n to the power 0.5 would be the smallest one among the polynomial ones. Then log n would be there after polynomial and constant like n square. But after this 4 we need to compare with f5, which is the last function. So you can see log to the first is f4, comparison between f4 and f5 is going on. Log of n raised to 1 and log of n raised to log of n. So both our bases are the same, so direct comparison is possible. So definitely 1 is less than log of n in terms of power, so it's f4 is less than f5. f3 is less than f5. So here bases are not same and there is no simplification happening. So apply, third step is apply log. So log n to the 0.5, then log of n to the log n. Then there we need to apply log formula, which is log a to the power b, which is b log a. 0.5 log n and log of n log n. So need to remove 0.5 because it's constant. So only here log n would remain, here log of n log n. And when we cut, like 1 log n is getting cut, 1 is less than log of n. Again we need to compare with f1 and f5, n square log of n raised to log of n. No direct comparison, no simplification, apply log. So log of n square. Here you can see log of n, when we apply log of n square, so according to rule of log, 2 would come in front and 2 log n would be there, but again 2 is constant, so remove 2, only log n would remain. And here you can see log of 3 times log, like first is log n and then log of log n is there. So log n get cancelled, 1 remains, and 1 is greater than log, so f2 is greater than f5. The last is n to the power log n and log n to the power log n. So powers are same, so we can do direct comparison. So where n is greater than log to the power log n. So this is the final relation we are getting. Since f5 is less than f2, so f5 would come before f2 in the final answer. So this thing you need to check where f5 will get fit. You need to see that. Thank you guys for subscribing and watching my video. I hope it helps.